Hello all, welcome back to Amruta's Blink. I am Amruta Kulkarni. Today we are going to look at basic problems of mensuration. We'll discuss few practice problems on area, perimeter and volume of 2D and 3D shapes in this video. Mensuration, practice problems on area, perimeter and volume of 2D and 3D shape. We'll see first problem of the video. A copper wire, when bent in the form of equilateral triangle of area 16√3 square centimeter. If the same wire is bent into the form of regular hexagon, find the area of the regular hexagon. Options are given: 4√3 square centimeter, 24 square centimeter, 32√3 square centimeter, 24√3 square centimeter and 48√3 square centimeter. Now what is given, first of all we will try to understand the problem. There is a copper wire. So copper wire will be let's say it is a straight wire. A copper wire when bent into the form of equilateral triangle. So from this wire you have created an equilateral triangle. Equilateral triangle means all three sides are equal. So let's say, and this equilateral triangle, it is given that it covers the area of 16√3 square centimeter. So when the area of equilateral triangle is given, we can find out the side of the equilateral triangle. Now we know the formula of equilateral triangle, that is √3/4 a square. Now this area is given as 16√3 square centimeter. So we can equate √3/4 a square is equal to 16√3. So let's say if the side of this equilateral triangle is A, then the area will be √3/4 a square, which is equal to √3. So now if we cancel this √3 and √3, we can say that a square upon 4 is equal to 16. That is, a square is now equal to 16 into 4, and hence 16 into 4, that is 64, and hence a is equal to 8 centimeter. So now side of this equilateral triangle is 8. Now what we need to do is, if the same wire is bent into the form of a regular hexagon, when the side of the equilateral triangle is 8 centimeter, so perimeter of the equilateral triangle will be 8 into 3, that is 24 centimeter. So obviously when the perimeter of this equilateral triangle is 24 centimeter, we can say that the given copper wire has a length of 24 centimeter. Now the same wire is converted to a regular hexagon. Regular hexagon has 6 sides. All 6 sides are of equal length. Hence we can find out the side of a regular hexagon by 24/6, that is 4 centimeter will be a side of this regular hexagon. And now in the problem they have asked us find the area of the regular hexagon, where side is nothing but 4 centimeter. So we'll find out the area of the regular hexagon, that is 6 into √3 formula for area of regular hexagon is 6 into √3/4 side square, which is equal to 6 into √3/4 into 4 square, that is 6 into √3/4 into 4 into 4. So this 4 and 4 will get cancelled. So 6 4s are 24. So which is nothing but 24√3 square centimeter, which is answer option D. Square root 24 into square root of 3 square centimeter will be the area of the regular hexagon, which is being created from the copper wire of length 24 centimeter. So in this problem there are 3 concepts are used. First is area of equilateral triangle, then perimeter of the equilateral triangle, again perimeter and area of regular hexagon. We'll move to problem number 2. A rectangular sheet of paper 44 cm by 10 cm can be exactly wrapped around the curved surface of a cylinder of height 10 cm. Find the radius of the cylinder. 7.5 cm, 6 cm, 7 cm, 1550 cubic centimeter and 1545 cubic centimeter. First of all, we'll try to visualize the problem. Now, what is being done is a rectangular sheet of paper. Let's say this rectangular sheet of paper, which is 44 centimeter wide and 10 centimeter in height, can be exactly wrapped around the curved surface area of a cylinder. So let's suppose you have this cylinder and you are wrapping this sheet of paper along the curved surface area of this cylinder. So the rectangular sheet will exactly cover the lateral surface, that is curved surface of the cylinder. So we can equate the curved surface area of the cylinder to the surface area of the rectangular sheet. Now, the width of the rectangular sheet, that is 44 centimeter, will be exactly covering the circumference of the cylinder. So when the width is 44 centimeter, we can say that the circumference of the upper surface or even lower surface of the cylinder is 44 centimeter. Now we know the formula for circumference, that is 2 pi r, and hence we can say that 2 pi r, that is 2 into 22 by 7 into r, is equal to 44. So 2 and 22 gives 44, so this gets cancelled and simply r is equal to 7 centimeter. So the radius of the base of the cylinder is simply 7 centimeter. Now the calculation part, this problem is very easy. Only the thing is you need to visualize this problem in a very correct way so that the solution of the problem becomes very easy. Hence answer option is C, that is 7 centimeter. We'll move to problem number 3. Circle of radius 7 centimeter are cut out from each face of the cube of side 44 centimeter. What is the ratio of the remaining area to the area cut from the cube? 7 as to 81, 81 as to 7, 1 as to root 7, root 7 as to 1 and root 11 as to 1. First of all, try to understand the problem. Circle of radius 7 centimeter are cut out from each face of the cube of the side 44 centimeter. So let's suppose this is a cube of 44 centimeter each side. Now what you are doing is you are cutting out a circle of radius 7 centimeter from each face of the cube. So here there is one cut, here there is one cut, here there is one cut. Similarly, it is from on all the 6 faces, something like which we do for our Diwali lanterns. First of all, we will calculate the total surface area of the cube. Now total surface area of the cube is 6 into side square. Side of a cube is given as 44 centimeter, so 6 into 44 square. We will keep this figure as it is as of now. Now a circle of radius 7 centimeter is cut out from each face. There are 6 faces. So the area which is cut out from the cubes are in the form of circle are 6 into pi r square, that is 6 into 22 by 7 into 7 square. So by simplification we will get 6 into 22 into 7. This figure also, this expression also we will keep it as it is. Now we need to calculate the ratio of the remaining area to the area cut out from the cube. So the required ratio is, how to calculate remaining area? Remaining area will be total surface area of the cube minus total area which is cut out in the form of circle. So 6 into 44 square minus 6 into 22 into 7 whole divided by 6 into 22 into 7. Now if I take 6 into 22 common, then we will have 2 into 44 minus 7 upon 6 into 22 into 20, 6 into 22 into 7. So this 6 and 22 gets cancelled. So we'll have 2 into 44 minus 7 upon 7, that is 88 upon 7 upon, that is 88 minus 7 upon 7, which is 81 upon 7, and hence the required ratio is 81 as to 7, which is answer option B. In this problem, if in the initial part of the solution, if you try to solve this expression, that is 6 into 44 square as well as 6 into 22 into 7, then the figures become bigger unnecessarily. So you can avoid the multiplication and division part by taking common. We'll move to problem number 4. A slab of iron 2 inches in length, 10 inches in breadth and 11 inches thick was melted and solidified into the form of a solid rectangular cone of radius square root of 21 inches. Find the height of the cone formed. 11 inches, 10 inches, 10.5 inches, 10.25 inches and 10.75 inches. Now in this problem we need to use the concept of volume. If you observe, all the units in this problem are given in the form of inches, but all the units are in inches, that is the same format of inch is used, so we can ignore the units and we need not convert them. A slab of iron of 2 inches in length, 10 inches in breadth and 11 inches thick was melted. So first of all we will find out the volume of this rectangular slab, that is volume of this rectangular slab will be LBH. Now the same slab is melted and converted in the form of a cone. So we can say that volume of the slab of iron and the volume of the cone which is getting formed are equal. Now volume of the slab is LBH and volume of the cone is 1 by 3 pi r square h. So we will write down LBH is equal to 1 by 3 pi r square h. Now length is 2 inches, breadth is 10 inches, height is 11 inches is equal to 1 by 3 pi r square. Radius is given as under root of 21. So r square is square of under root of 21, that is 21 into h, and we need to find out this h. So upon simplification we will get 2 into 10 into 11 is equal to 1 by 3 into 22 upon 7 into 21 into h. So we can cancel out this 7 into 3 and this 21. So we will get 2 into 10 into 11 is equal to 22h. Now this 2 into 11 and this 22 also gets cancelled, and we can simply get h is equal to 10 centimeter, and this h is height of the cone formed, and hence height of the cone formed is equal to 10 inches, which is answer option B. we'll move to last problem of the video. A cylindrical cistern of radius 8 cm is partially filled with water. 3 solid spherical balls of radius 4 cm are completely immersed in the water. By how much will the water level in the cistern rise? 4.5 cm, 4 cm, 3.5 cm, 5 mm and 3.8 mm. If you observe the options, few options are given in the form of centimeter and option D and E is given in the form of millimeters. So it is obvious that whenever you are solving the problem, you need to give utmost care to units also. First of all, we'll try to visualize the problem. Originally there is a cylinder which is, let's say, which is filled with water up to height 8 cm, that is small h. Now in the second figure, what you are doing is you are immersing 3 spherical balls into this cistern, and because of which later on, let's say the increased height is capital H and initially the original height is small h. So if we assume the original water level is small h, then from that we can find out the original volume of water. Now we know that the volume of a cylindrical shape is calculated by the formula pi r square h. So original volume of water is pi r square h, that is pi into 8 square into small h. So we have pi r square h, that is original volume of water. Now 3 solid spherical balls of radius 4 cm are completely immersed in water. So we'll find out the volume of these 3 spherical balls. Now volume of a sphere is 4 by 3 pi r cube. So volume of these 3 spherical balls will be 3 into 4 by 3 pi r cube. R radius is 4 cm. So we have 3 into 4 by 3 pi into 4 cube. So the revised volume of water will be original volume of water plus this volume of these 3 spherical balls. So revised volume is pi 8 square into h, that is small h, plus 3 into 4 by 3 pi into 4 cube. Now after immersion of these solid spherical balls, the height, the assumed height is capital H. So the revised volume of this water is pi r square h with capital H. So pi into 8 square is into capital H. Now we can say that this pi 8 square into capital H is equal to pi into 8 square into small h plus 3 into 4 by 3 pi into 4 cube. Now we will take out pi common, and from that we can cancel out pi. So we will have 8 square into h. This pi we can cancel from all the terms. So 8 square into h, that is 64 capital H, is equal to this 8 square into small h, that is 64h, plus this 3 and 3 get cancelled. So you have 4 raised to 3 into 4, that is 4 raised to 4. So 64 capital H is equal to 64 small h plus 4 raised to 4. That is 64 h capital H minus small h, that is the difference in the height. That means by how much will the water level rise in the cistern? In the question it is being asked that by how much will the water level in the cistern rise. That means we need to find out just the difference in the height. That is, we need to find out this part capital H minus small h. So 64 into this capital H minus small h is equal to 4 raised to 4. Now we know that 64 is 4 cube, hence we can say that 4 cube is equal to, we can say that 4 cube into h minus h is equal to 4 raised to 4. Hence 4 cube and this 4 raised to 4 get cancelled. There will be just 4. So capital H minus small h is equal to 4, and hence the difference, that is by which number the water level will rise in the cistern, is just 4 centimeter, which is answer option B. Therefore increase in the height is 4 centimeter, which is answer option B. In this video we have seen 5 practice problems on mensuration. In upcoming videos we will see few more problems and new concepts. Stay tuned with Amruta's Blink for more content. Thank you.